Hello everybody, welcome back and thanks again for watching these videos. I really do hope they're helping you out. Today I'd like to do a quick video on scientific notation and the 4 operations that we can do in scientific notation. So first I'm going to start with multiplying and dividing. They tend to be the easiest. Remember, we're going to divide and multiply our digits normally, and we'll use our exponent rules to simplify. So with our first problem, I have 3.2 and 5.2. I'm going to multiply both of those. That will give me 16.64. Totally okay to use a calculator on those. That's actually what I did. Then we're going to take our exponents and use our exponent rules of adding the 4 and the 3. So that's going to become times 10 to the 7th power. Now if you're saying to yourself, okay, but wait a minute, that's not scientific notation right there. You're right. We're going to have to adjust this. I'm going to move my decimal back one. Now it's 1.664, and that went down one. My exponent will then raise by 1. 1.664 times 10 to the 8th power. Boom, we're done. Didn't have to deal with a lot of zeros at the end or park them and put them back. It was a quick way to do the problem. For a division, same idea. Divide the two digits. 8.24 divided by 2. That's going to give me 4.12. And for my exponents, I'll use my subtraction rule. Negative 5 minus 2 will equal negative 7. Now see, weren't you glad you didn't do long division on that? Think of all the leading zeros you'd have. That was quick. When we're dealing with adding and subtracting, the only time shortcuts really work is if both of the numbers have the same exponent. It's like having common terms. So, for example, if I have 4 times 10 to the third plus 2 times 10 to the third, we're really saying 4,000 plus 2,000. Well, 6,000. We can do that mentally. And the shortcut would just be add the 4 and the 2, keep your exponent and the power of 10. As one of my classes mentioned yesterday when I first introduced this, so what do we do then if we don't have the same powers? The idea is we're going to switch one of them. We're going to shift a decimal left or right, and then we'll adjust an exponent accordingly. Let's take a look at a couple of those. I have 1.6 times 10 to the 7th, so we're talking like 16 million. And then we have 5.2 times 10 to the 6th, 5,200,000. Now we could just write those all out in standard form. That would be a lot of zeros. It's easy to make mistakes and lining up things wrong. So let's look at it in scientific notation. If I move my decimal down one on the 5.2 times 10 to the 6th, I can adjust my exponent up 1. Then I'll have 1.6 times 10 to the 7th plus 0.52 times 10 to the 7th. There we go. Now I can just take my two leading digits and add those two up normally. That'll give me 2.12. And I'll keep my 10 to the 7th. One thing before I continue. Sometimes students ask, well, what's easier, if I take the larger one and shift down, or if I take the smaller and shift up? I tend to find it's usually easier if you take the smaller exponent and shift up, and that way you usually won't have to do an adjustment at the end. But really, whatever you think is going to work easier for you is the best way. I'll show you one more, and I'm going to use the going down and up method to match with a higher exponent. Meaning, I'll take my 4.51, I'll move my decimal down one or left one, and I'll move my power of 10 up one. This will give me 0.451 times 10 to the 5th power. Now I can subtract my 8.796 and 0.451 normally. When I'm done with that, I'm going to have 8.345, and I can just keep the matching 10 to the 5th power. I know that was pretty quick. I just reviewed all 4 operations in scientific notation with you. I hope this helped you out, and if you have any questions, please, 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 as always, come ask me. And again, thanks for watching.